Hello viewers, this is a demo video for your GATE classes. In GATE, what we are looking for, what is GATE? First of all, this is Graduate Aptitude Test for Engineering, an entrance exam which is a gateway to the premier institutions of India, that is IITs and NITs, and some of the cases these scores are applicable to some engineering institutes in Germany as well. So how do we look at the problem in the gate? The gate problems should be looked in a different way, not in the ordinary way. Your concept should be very clear, as well as you should have some of the intricacies, so that the ordinary way of looking into the problem will not help sometimes, most of the times actually. Suppose we are discussing one mathematical problem right now. In mathematics, we'll do one problem for eigenvalue. What is eigenvalue? Suppose you are given a matrix A. The theory is you are given a matrix A. It may be 2 by 2, it may be 3 by 3. You have to find out the value of A minus lambda I. Take its determinant, equate it to 0, find some values of lambda, that is say lambda 1, lambda 2 in the case if it is a 2 by 2 matrix. If it is a 3 by 3, you will get 3. This is the ordinary case, or this is how you have learned till date. Now I will show you that how do you save the timings. Suppose you are given this problem. Say your matrix is 2, 3, 4, 3, and you form A minus lambda I. Lambda will be your eigenvalue. So 2 minus lambda, 3, 4, 3 minus lambda. It is the determinant. Mind, there is a difference between this bracket, which is a matrix. It doesn't boil down to a single value, whether the determinant is always having a single value. We have made it into determinant, then equate it to 0. It will give you, if you multiply 2 minus lambda into 3 minus lambda minus 4 into 3, 12. That will give you lambda square minus 5 lambda minus 6 equal to 0. That is lambda minus 6 into lambda plus 1 equal to 0. So we have two values of lambda, that is 6 and minus 1. Now the question which came in 2009, I'll give you one example. That in 2009 a question came where you are given the matrix and you are asked to find the eigenvalues. This is question number in 2009. If you open the 2009 paper, you will get it. Minus 1, 3, 5, minus 3, minus 1 and 6. This is 0, 0, 3. Now ordinarily you are supposed to think, okay, it will not do any kind of harm, so I can find out there are two zeros, so calculation will not be that difficult. So I do that. A minus, this is A, your matrix, which is given A minus lambda I. Even if you are multiplying, take its determinant. So this into this into this minus this. Now you are tempted to think in this way. We will multiply minus 6 into 0, okay, minus 3 this into this, 6 into 0, 0 again, plus 5, this into this into this, so altogether 0. Now you have to find out this equation, solve it, get some values. Now you see, when I am multiplying all these terms, it will definitely give you a equation in polynomial which is in the third order, and therefore you will get 3 values of lambda. This is the ordinary way to do this. Ordinary people think like that, but as you are appearing for gate, your thinking scale should be different. You will have to use some of the tricks that I have already told you. You need to know some tricks. What is that? That is a property of the matrix. What is property of matrix? That is, sum of the diagonals is equal to sum of your eigenvalues. Now you are provided 4 options, A, B, C, D. This matrix was given, the question was this matrix was given, and there were 4 values given, and you have to tell what are eigenvalues. So I will use a shortcut method like this. I will rather write down this was 3 plus 5j, 6 minus j, minus 6 plus 5j. You can see from the options given you can easily think that these values, these equations is leading you to some imaginary number. She was 3 plus j, 3 minus j, 5 plus j, 3 minus 1 plus 3j, minus 1 minus 3j. So what I should do, I should not go into all this a minus lambda calculation. Rather, I will just add it up, sum of the diagonals, minus 1 plus 3. That is the sum of diagonals, which is equal to 1, correct? Minus 2 plus 3, that is 1. So sum of the diagonals is 1 in this case. I will try to find out where I can do that diagonals. So sum of the eigenvalues. These eigenvalues have already been provided in the question paper. These are your multiple choices. So this is the one. Plus 5 minus j. No, because this is a real number. Plus 5 plus j minus j. No, some j's are coming. Plus j minus j and plus j once again. No. Plus 3j minus 3j. So this will be the correct option. If you add it, minus 1 and plus 3. So 3 minus 1 that will lead to 1, and this 3j gets cancelled. So sum of the diagonals and sum of the eigenvalues are equal, so D will be the correct option. This is the one way how you use the properties of matrix. Most of the cases you should use the properties of matrix, otherwise you will have to, it will lead to a very lengthy calculation which you cannot afford to waste the time, right? Thank you.